Welcome back, my friends. So in the first video on quadratic functions, we identified key characteristics. We looked at how the graph of the parabola is related to its quadratic function, and I gave you a bunch of formulas for us to use. So now I'm going to draw the graph of a quadratic function given its general form, and we're going to use all these formulas that we found in the last video. So make sure you have these pulled up in your notes and you're ready to use it. And we're going to go through this example right here. So I'm going to say, here's our parabola. Here's our example. I want you to graph f of x is equal to x squared minus 3x minus 10. If you'd like, you can pause the video here, see if you can graph it yourself, and then check your work with me. Or you can just follow along and take notes. Whichever way you think is going to help you learn the best, you're free to try. So the first thing I'm going to notice here is I'm going to take a look at what my A, B, and C values are, because I know that I'm going to need those values to plug into my formula. So we're going to find A, B, and C. My coefficient for A is unwritten here, which means that that coefficient is 1. My B value is -3. And my C value is -10. So now I know what A, B, and C are, and I'm going to use those throughout all of my formulas to graph this puppy here. And I'm going to start off by finding my vertex. I know that my vertex is at the point x is equal to -b divided by 2a. So what I'm just going to do is plug in my b value here and plug in my a value here. So my b value is -3. So what this is going to tell me is that that's actually -3 divided by 2, and my a value is 1 here. So these two negative signs, I have the opposite of a negative number, which is a positive number. So I end up with +3 divided by 2. So that is the x coordinate of my vertex, 3/2. To find the y coordinate, I'm going to plug in 3/2 into my equation. So everywhere that I see an x value here, I'm going to plug in that value, and then I'm going to solve and simplify. So this is going to be 3/2 squared minus 3 times 3/2 minus 10. So that's going to give me 9/4 minus 9/2 minus 10. I've got some fractions here, so I'm going to need to find a common denominator. So I'm going to multiply by 2/2 here. I'm going to treat this as the fraction 10/1 and multiply it by 4/4. So then I get 9/4 minus 18/4 minus 40/4. And that's going to give me 9/4 minus 58/4. That's going to give me -49/4. Let me check and see what that decimal is. That's going to be equal to -12.25 if you do the decimal form. Decimal or fraction doesn't really matter. You can use either one. So my vertex here would be the point 3/2, comma -49/4. Or as a decimal, you could definitely say 1.5, comma -12.25. So this is the vertex. So that's going to be the point of my parabola at the bottom of my U shape. Notice I say the bottom of my U shape. I know this because my A is a positive number here. My A was equal to +1, so that parabola opens up. In fact, let's write that down. Opens up because my a is greater than 0 in this case. So I already know a little bit about this parabola. I have a vertex. I know it opens up. Next thing I want to do is find my x-intercepts. I'm going to do that using the quadratic formula. There's more than one way to do it. That's just the way I choose. So I know that I'm going to need to use my x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And I'm very careful when I use my quadratic formula because I don't want to make any little errors and mess myself up. So I always write down what my a, b, and c values are, again, just to make sure that I substitute everything in correctly. Sign errors are really common here, so I really want to pay attention to my signs. So I have a is equal to 1, b is equal to negative 3, and c is equal to negative 10. And just to be super careful, I'm going to go through and say a is equal to 1. So that should go here and here. B is equal to negative 3. So that should go here and here. And C is equal to negative 10. So that should go here. So I'm going to plug in those values. X is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times a is 1 times c is negative 10. And that whole thing is divided by 2 times a is 1. Notice my parentheses use here. I'm putting in parentheses everywhere that I drop that value so that this way I can keep my signs correct and kind of know what I'm talking about here. I plugged in my b value here. And so the formula tells me it's the negative b value. So this negative that I wrote here in white is part of the formula. And that helps me know that this negative 3, that we're going to cancel out and actually get a positive 3. Similarly, underneath my radical symbol here, when I did the negative 3, I put it inside parentheses to square it. Inside parentheses, because I know that negative 3 inside parentheses squared like that is actually positive 9. And here's where the signs really matters in this next little piece of the statement. I have a negative that's a part of my formula, and then a negative value for c. So I have the negative times a negative, which will give me a positive. Gives me plus 40. And that's all divided by 2. So then this simplifies to 3 plus or minus the square root of 49 divided by 2, which simplifies to 3 plus or minus 7 divided by 2. And now here's where the plus or minus magic comes in. This gives me 2 answers. 3 plus 7 over 2, or 3 minus 7 over 2, plus or minus. So then I get 10 divided by 2, or negative 4 divided by 2. And this gives me 5, or negative 2. So my x-intercepts in this case would be the points 5, 0, and the point negative 2, 0. The next thing I'm going to do is find my y-intercepts, and then I will be ready to go. So my y-intercepts take much less calculation. I say intercepts, but there's only one. There's only one y-intercept. And so I'm going to have that. That's going to be the point 0, comma, f of 0. So just like I plugged in, I'm just going to plug in 0 for my x value into my original equation. And that's going to give me my y-intercept. So anywhere that I see x, I'm going to replace that with 0. So I have 0 squared minus 3 times 0 minus 10. So this gives me 0 minus 10, which is negative 10. So my y-intercept will be the point 0, comma, negative 10. So we've got all of our key points. Let's stick them together and get a beautiful graph. Why don't we? Why don't we? right. So our vertex is the point 3/2 and negative 49/4, which is about 1.5 and negative 12.25. So let's count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a little bit. So when you have a decimal value or a fractional value, it's okay to estimate, right? This is not exact, but I'm graphing by hand, which is all right here. So that's my vertex. And you want to go ahead and label your vertex. And go ahead and give the coordinates when you graph by hand. That way your teacher knows that it's a bit of an estimate because you're dealing with fractions and that that's okay. So there's our vertex. The next thing I'm going to plot is our y-intercept. So our y-intercept is the point 0, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's this point here. And again, I'm going to say, label your point. Y-int is fine with me. I know what you mean. You can use abbreviations. That's all right. So there's our y-intercept. Our x-intercepts are the points 5, 0, and the point negative 2, 0. And these are our x-intercepts. And now we have enough to graph this parabola. Just draw the general shape through your points. I'm not the greatest artist, but you do want it to be vaguely U-shaped, because you know that's what it's supposed to look like. And that would be it. Oh, I almost forgot our axis of symmetry. We know that that's the line that cuts us right in half here, that goes through the vertex. I'm even going to do it in red, just for grins and giggles. So here's our axis of symmetry. And I do want you to label this as well with the equation. I want you to label this as x is equal to 3/2. It's not a coincidence that this and this are the same. The axis of symmetry will always cut right through the vertex. That's how it's always going to be. And this is a final graph. If I were going to turn it in for homework, I would want to go ahead and make my axes prettier. Draw these arrows to show that they go off forever and ever. Label my x and y axes. And that would be great. You could turn this in for homework and I'd be pleased as pie. This would be fine. I can't judge your artistic skills because you can see mine are a growth area. This would be worth full points. All right. So hopefully that helps you know how to graph some of these for your homework. If you have questions, definitely write them down and bring them to lecture. We'll talk about them. I'm going to see you in the next video. I think we can check off of our list here that we now know how to draw the graph of a quadratic function. I'm going to check that right off. The next little bit, we're going to do a couple more problems in the next video. I think I'm going to save actually minimum and maximum value problems for our time in lecture. I'm going to show you how to find the domain and range of a quadratic function and to use the standard form of a quadratic function, which we haven't talked about yet, to write the equation given a graph. So we're going to do that in 2 more videos. I will see you in the next one. Stay safe, my friends.